The question of whether an 800 amp, 100% rated breaker can be fed with two sets of 500 kc male cables, each rated at 380 amps at 75 degrees Celsius, resulting in a total ampacity of 760 amps, can be addressed by considering several factors. Yes, it is permissible to feed the 800 amp breaker with the described cable configuration provided certain conditions are met. Firstly, current carrying capacity is paramount. The combined ampacity of the two sets of cables must be equal to or greater than the breaker rating. In this scenario, the total ampacity is calculated as 2 times 380 amps, which equals 760 amps. While 760 amps is less than the 800 amp breaker rating, the NEC provides allowances for such situations under specific circumstances. Secondly, compliance with the NEC is crucial. The NEC permits the use of multiple conductors to supply a single breaker, but strict adherence to code requirements is mandatory. This includes ensuring that the conductors are appropriately sized and connected according to NEC guidelines. The NEC addresses conductor ampacity in Article 310. The specific sections relevant to this situation depend on factors such as the installation method, ambient temperature, and the presence of other current carrying conductors. It is essential to consult the appropriate tables and sections within Article 310 to determine the allowable ampacity of the 500 kc mil conductors under the specific conditions of the installation. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. If the 500 kc mil conductors are installed in a manner that does not allow for free air circulation, such as in conduit, the ampacity may need to be derated based on the number of current carrying conductors in the conduit. NEC Section 310.15b3 outlines the adjustment factors for multiple conductors in a raceway or cable. If there are more than 3 current carrying conductors in the conduit, the ampacity of each conductor must be reduced according to the adjustment factors in this section. Furthermore, ambient temperature correction may be necessary. NEC Section 310.13b2 provides guidance on correcting conductor ampacity for ambient temperatures other than 30 degrees Celsius (86 degrees Fahrenheit). If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductors must be reduced according to the correction factors in this section. If the ambient temperature is lower than 30 degrees Celsius, the ampacity may be increased, but this is less common in practice. In addition to ampacity derating and ambient temperature correction, it is important to consider voltage drop. Voltage drop occurs when the voltage at the load end of a circuit is less than the voltage at the source end due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 210.19 AM provides guidance on voltage drop in branch circuits, and NEC Section 215.2 AM provides guidance on voltage drop in feeders. The NEC recommends limiting voltage drop to no more than 3% in branch circuits and 5% in feeders. To calculate voltage drop, it is necessary to know the length of the conductors, the current flowing through them, and the impedance of the conductors. The impedance of the conductors can be obtained from manufacturer's data or from NEC Chapter 9, Table 8. If the calculated voltage drop exceeds the recommended limits, it may be necessary to increase the size of the conductors or reduce the load in the circuit. Thirdly, temperature rating is a critical consideration. The cables being used are rated for 75 degrees Celsius, and it is essential to ensure that the breaker also has a compatible temperature rating. This compatibility ensures that the cables will not overheat when carrying the breaker's rated current. Breaker temperature ratings are typically found on the breaker's label or in the manufacturer's specifications. It is important to verify that the breaker is suitable for use with 75 degrees Celsius conductors. If the breaker is only rated for 60 degrees Celsius conductors, the ampacity of the 500 kc mil conductors must be reduced to the value corresponding to the 60 degrees Celsius rating. This is because the weakest link in the chain determines the overall ampacity of the circuit. Fourthly, proper termination is essential for safe and reliable operation. The cables must be properly terminated at both the breaker and the load side. This ensures good electrical connections and prevents the overheating. Terminations must be made using appropriate connectors and methods, and they must be torqued to the manufacturer's specifications. Improperly terminated connections can cause excessive heat buildup, leading to insulation damage, conductor failure, and even fires. NEC Section 110.14 provides general requirements for electrical connections, including requirements for tightness of connections. The NEC also requires that conductors be terminated in a manner that does not damage the conductors or their insulation. This is particularly important when using large conductors such as 500 kc mil, as they can be easily damaged if not handled carefully. In addition to the NEC requirements, it is important to follow the manufacturer's instructions for terminating conductors. The manufacturer's instructions will typically specify the type of connector to use, the torque to apply to the connector, and any other special considerations. Failing to follow the manufacturer's instructions can void the warranty on the equipment and can also create a safety hazard. Fifthly, the 100% rating of the breaker needs to be considered. A 100% rated breaker is designed to carry its full rated current continuously without tripping. However, it is still important to ensure that the conductors are sized appropriately to carry the load. In this case, the total ampacity of the two sets of 500 kc mil conductors is 760 amps, which is 95% of the breaker rating. This is generally acceptable, as long as the load on the breaker is not expected to exceed 760 amps continuously. If the load is expected to exceed 760 amps continuously, it may be necessary to increase the size of the conductors or use a larger breaker. Furthermore, it is crucial to consider the specific application and the nature of the load being served. If the load is intermittent or variable, the actual current draw may be significantly less than the breaker rating. In such cases, the 760 amp capacity of the cables may be sufficient. However, if the load is continuous and constant, it is essential to ensure that the cables are adequately sized to handle the sustained current flow. Additionally, coordination with other protective devices in the electrical system is necessary. The overcurrent protection devices, such as fuses or other breakers, must be properly coordinated to ensure that they trip in a selective manner, preventing unnecessary outages and minimizing downtime. Coordination studies are often performed to determine the appropriate settings for the overcurrent protection devices. Furthermore, it is important to consider the available fault current at the breaker location. The available fault current is the amount of current that would flow in the event of a short circuit. The breaker must have a sufficient interrupting rating to safely interrupt the available fault current. The interrupting rating of the breaker is typically marked on the breaker's label. If the available fault current exceeds the interrupting rating of the breaker, it may be necessary to install a current limiting device such as the fuse upstream of the breaker. In summary, while it is generally permissible to feed an 800 amp, 100% rated breaker with two sets of 500 kc mil cables, each rated at 380 amps at 75 degrees Celsius, it is essential to carefully consider all of the factors discussed above. This includes ensuring that the total ampacity of the cables is sufficient to carry the load, that the NEC requirements are met, that the temperature ratings of the cables and breaker are compatible, that the cables are properly terminated, and that the breaker is properly coordinated with other protective devices in the electrical system. A licensed electrical engineer or qualified electrician should perform a thorough review of the specific installation to ensure compliance with all applicable codes and standards. Consider a calculation to verify the suitability of the cable configuration. The total ampacity is calculated as 2 times 380 amps, resulting in 760 amps. The percentage of the breaker rating that the cable ampacity represents is calculated as 760 amps divided by 800 amps, multiplied by 100%, resulting in 95%. Since the total ampacity is less than the breaker rating but the percentage of breaker rating is below 100%, the configuration is likely within acceptable limits, provided all other NEC requirements are met. It's always recommended to consult with a qualified electrical engineer or inspector to confirm that the installation complies with all applicable codes and standards.